Hi guys, welcome to your your chapter 2, lesson 6 notes on ratios, rates, and conversions. By the end of the day, you will be able to find ratios and rates and also convert units and rates. So let's start out with a race. You have two runners and they each did a separate race length and there are their times. Who is the faster runner? So what we're going to do here is we are going to compare their times. We're going to find out what their times and their race length. We're going to figure out how fast did they run each distance. Okay? So we start out with Ronald Distradio, and let's go ahead and put the distance over the time, because that will give us the rate. You remember from our last lesson, we had the formula distance equals rate times time, and then to solve for their rate, because we know their distance is here in meters and meters. That's a distance. So we know their distance, and we also know their time in seconds and in seconds. So we know distance, we know time. We want to solve for the rate. So we know distance equals rate times time. We divide both sides by time to get distance over time equals their rate. I don't know what happened to my pencil, but here it is. So we're going to use this same equation. Rate equals distance over time. So let's plug each of their times in. So for Ronald Distradio, his distance was 800 meters. So that's 800 meters. Oops, forgot my meters. 800 meters over 116 seconds gives us his rate, his speed of 100 divided by 116, which is approximately 6.897, and then we have meters per second because we got meters over seconds. So that was Ronald's rate. He can run at basically 6.9 or 7 meters per second. And then we have Miles Rhodes, and he's running at 1,500 meters, and he runs 1,500 meters in 338 seconds. So that gives us his distance is 1,500 meters divided by a time of 338 seconds. And his time comes out to about 4.439 meters per second. So who runs faster? Who has the higher rate? Well, that'll be our Ronald Distradio here. He is faster. In case you're curious, 80 meters is about half a mile. It's 2 laps around a track, so that's about a half a mile. And 1,500 is just under 4 laps around the track, so that's about 1 mile. And, 116 seconds is a minute 56 seconds. So just under 2 minutes, and 338 is 3 minutes 58 seconds. No, that's a lie. Not 58 seconds. Excuse me. 3 minutes and 38 seconds. So you have Miles who's running who's running under a mile in just under 4 minutes. That's very fast. But you also have Ronald Distradio who's running about a half a mile in about 2 minutes. So he is running faster. Cool, huh? Yeah, good job, guys. Okay. So what we did here is we created two things called ratios. And a ratio compares two numbers using division. And that's exactly what we did up here. We took our distance and divided it by time. That's division, and there we got a ratio. So the ratio of two numbers, A and B, we can't have B over 0 because we can't divide by 0. We can write a ratio in 3 ways. We can write it as a division problem, or we can write it as a division problem, or we can, I'm just kidding. It is division. Or we can write it as a ratio with like this colon right here. Or we can write it in words saying A to B. This is my favorite because I love fractions. You will often see ratios like this, especially when expressing odds, or you can write them. So a ratio also expresses a multiplicative relationship because multiplication is the opposite of division. However, for this class, we're going to consider ratios a lot like dividing. So we're going to kind of mute that a second. So here we go. If the ratio of the number of boys in this class to the number of girls in this class is 2 to 1, then we say the number of boys is 2 times the number of girls. This, I think, is approximately true for our class. I don't know. I would have to look it up again. But if boys to girls is 2 to 1, then for every boy, we have twice the number of girls. Our key idea of the day is going to be in yellow because it's a key idea. So here we go. You can write ratios and find unit rates to do two things. First, you can compare quantities, and then you can also convert units, and you convert rates, they're just units, to solve problems. Convert means change. So if I needed to convert meters per second, for example, to miles per hour, that would be a conversion. We're changing it into a different unit, into a different rate. So this is our This is our key idea of the day. It is our goal. So let's go ahead and commit our goal. Commit, achieve, accomplish our goal. We'll go shopping. So you're shopping for shirts, and shopping in order to get shirts. Which store offers the best deal? In order to find that out, let's create a ratio. We're going to divide the cost per the number of shirts because we want to find the cost of each shirt, the cost per shirt. So our blouse boutique has a ratio of $25 for 2 shirts. Again, we're following this pattern of the price, the cost for the number of shirts that we have. And if we were to work that out, we're going to say that that is approximately $12.50 for each shirt. See how we are dividing by 1 right here? This division by 1 is what we call a unit rate. A unit rate is any rate that's over 1, like uno in Spanish is 1, or a unicycle has 1 wheel, or a unibrow is when you have your 2 eyebrows, but then they form 1 big eyebrow over both your eyes. Okay, unit means 1. So a unit rate is when you express a ratio with 1 in the denominator. So we're going to do that for each item here. We create a ratio, and for T-shirt town, we know that if we spend $45, we will get 4 shirts. And our unit rate there, our price for every 1 shirt, is $11.25. Awesome. That's cheaper than Blouse Boutique. And then finally we go to Jersey Junction, where we pay $30 for 3 shirts, which is a unit rate of $10 per shirt. So that is our winner chicken dinner. We will want to buy shirts from Jersey Junction. Fun fact, Jersey Junction is actually the name of an ice cream shop where I went to college. So, oh look, there's our instructions, and we did them. We write each price, each overall price as a ratio, and then we found which one had a unit rate, the lowest unit rate to compare. So Jersey Junction is our winner. Can I just write Jersey Junction? Has the best deal because its unit rate is the lowest. it has the cheapest price per shirt. Cheapest per one shirt. Right? Awesome. Let's go to our next idea. Our next idea is called a conversion factor. A conversion, you'll remember convert means to change. A conversion factor is a ratio that we can use to convert to units. And we always have to have two equivalent measures. They need to be equal to each other. For example, we have 12 inches in 1 foot. This is also a unit. Okay. We have 12 inches in 1 foot. Or we have 1 kilogram is 2.2 pounds. Or we can say there are 1,609 meters in 1 mile. You don't always need to have 1 in there. These all happen to have 1, but it's not always the case. Okay. Our second key idea of the day is that if you want to convert from one unit to another, you need to multiply the original unit by a conversion factor that will get you what you want, by a conversion factor that produces the desired unit. So how come this works? Why can we use a conversion factor and then it won't mess up anything? Well, check it out. Conversion factors are equivalent measures. And when you have anything divided by itself, if you have like A divided by A, that's always equal to 1. So conversion factor is always equal to 1, and that won't ever change anything. Okay. So let's do some conversions here. And for the interest of time, we're not going to do the middle one. So don't worry about it. Okay, cool. So what do we want to do? Well, we want to find a good conversion factor as our first step. So I want to find what relates minutes to hours. So we start out with a good conversion factor. Well, I know that there are 60 minutes in 1 hour. I learned that when I was like 7. I'm so proud. Okay. However, I want to write that as a conversion factor. So I'm going to say 1 hour is 60 minutes. Write it as a fraction. And then I will multiply what I started with times my conversion factor. So I'll do 330 minutes. And then remember, we multiply times 1 hour and 60 minutes. Now, if we set it up right, remember that we can always divide by 1 and that doesn't change anything, right? If we set this problem out right, then our units will cancel out. We'll have minutes divided by units. Minutes divided by minutes. It's very important that you set up your units to cancel out, to divide out. So you need to have 1 on top, 1 on bottom. Okay. Well, I guess I got ahead of myself. This should be here. We don't need to do all this work up here. There we go. So that's equal to this. And then we simplify that out. So we have 330 over 1 times 1 hour over 60, which is 330 over 60. 330 divided by 60 is 5.5. So that gives us 5.5 hours. So if you see a movie that's 330 minutes long, you better be ready to take a potty break, because that's 5.5 hours of your life you're committing to this movie. Okay. Well, what if you need to measure something totally in inches, and you know that you are 5 foot 3 inches? I need to convert all those to inches. You think back to a long time ago where you learned, oh, I know 1 foot is 12 inches. Yay, good job, me. All right, now we need to convert that 5 foot into inches, and then we'll add the 3 inches because that's already in inches. So we're going to set this guy aside for right now, just kind of leave him as an afterthought because he's already in inches. Super duper. Already in inches. Okay, so we'll just kind of leave him off to the side for a second. For a second, or, a 60th of a minute. Conversions. Okay, so we've got 5 feet. We started out with feet. Times, we need to create a conversion factor with what we know. We could do 1 foot over 12 inches, but when we multiply, that won't cancel out. So we need to change our order around, and we need to say 12 inches over 1 foot. Because we need to be able to divide out our common units. That's the same thing as 5 feet over 1 times 12 inches over 1 foot. And now that we're multiplying, the feet will cancel out. So this is the same thing as 60 inches over 1. Oh, that's 60 inches. Nice. Or rather, I got that 60 because it's 5 times 12 equals 60 inches. But remember, we have this plus 3 on the side going the whole time. So that's actually 5 foot and 3 inches is equal to 63 inches in total. Yay! So make sure you're keeping your units in the right spot. This is a great way to check your work too. By keeping your units in the right spot, you need to make sure that your units work out so you don't get lost in your problem. Like my minutes canceled out with my minutes, my feet canceled out with my feet. In case you ever need a hand with that, be sure to speak up and I would love to help you out. Okay. So notice that every time we're doing each step of the calculations, the units are in there because the units will help us determine the actual unit for the answer. And if we end up with a wrong unit, we must have done something wrong. So this process has a name, and then we're going to spell it correctly. It's called a unit analysis. It's also called dimensional analysis because you're looking at different dimensions. But we've been talking about units, and we call like feet and inches and miles, we call those units. So unit analysis, also known as a dimensional analysis. There you go. So in Canada, we have this tower that's 1,815 feet tall. How many meters tall is the tower? We're going to use this fact that 1 meter equals 3.28 feet. So let's come up with a conversion factor. We're either going to say 1 meter over 3.28 feet, or we'll use 3.28 feet over 1 meter. How do we know which one is better, but is better to use for this problem? Well, let's see what we're starting out with. We're starting out with 1,815 feet tall. Sorry, I meant to do this kind of thing, but this works out well. We have 1,815 feet is what we start out with. And we want to figure how are we going to divide out common units? Well, what's going to divide out? Feet over feet or feet over meters? We want feet over feet. So our first instinct was correct when we multiply these guys together. Again, we went with this one, meters over feet. We can rewrite this so they all fit in the same window as 1,815 feet times 1 meter over 1 times 3.28 feet. And now that we have feet over feet, these guys are going to cancel out. They're going to reduce out. So that gives us 1,815 meters over 1 times 3.28 is just 3.28. Oh, sorry, the feet got canceled out. Yay, just 3.28. Awesome. And then we do whatever that division is. 1,815 divided by 3.28 is 553, approximately 553 meters. Now let's check our work in the efficient way. We're going to check our work with mental math. We don't have to completely redo the problem. We'll just check if we're about in the right spot. So 1815 feet is what we started with. And that's about 1,800 feet. It's close enough. And then 1 meter is about 3 feet. About. It's close. Okay, we're just checking our work to see if we're in the right spot. And if we divide both of those, 1,800 feet divided by 3 feet is approximately 600. Oh, right, and the feet canceled out, right? So do we have about 600 meters? Yeah, it's about. We're close. So we probably did something right. Yeah. Okay, now let's see how fast our runner can run in miles per hour. So we've got our lovely runner, Mia. She runs a 50-yard dash in 5.6 seconds. So how fast can she run in miles per hour? Well, shoot, you guys. We don't even have miles or hours listed in this question. But let's take it one step at a time and see what we can do. What do we know? We know she's got 50 yards in 5.8 seconds. So that's 50 yards in 5.8 seconds. What else do we know? Well, I'm going to tell you that there's 1670 yards in a mile. I'll just give that to you. That's for free. Okay, but how many seconds are there in an hour? Shoot, I don't know off the top of my head, but I do know that there are 60 seconds in a minute. And I also know that there are 60 minutes in an hour. So I'm going to put those two together, and that'll be close enough. Okay, are we there yet? What do we know? Okay, so we have our yards canceling out. We're canceling out units now. We have seconds and seconds. We have minutes and minutes. Notice that I'm crossing out a unit on top with a unit on top with bottom, on top, and bottom. Now, what units are we left with? We're left with miles on top and hours on bottom. Hey, that's what we need. Miles per hour. Now we just do a lot of fancy math stuff. What is left? We crossed out a lot of things. What do we have left? Well, on top we have 50 times 1. I'm not going to rewrite that though. Times 60. Times 60 again. And then the unit up here, the only one that's not canceled out is miles. And then on bottom, what do we have? Well, we start out, with 5.8 times 1670 times 1, which is, I'm not going to rewrite that, times 1 hours. Sweet. So 50 times 60 is 180,000 miles over 5.8 times 1670 is 10,208 hours. All right, you guys. So Mia can run 180,000 miles in 10,208 hours. Isn't that so helpful? No, that's not helpful at all. Okay, we reduce that. That's approximately 17.6 miles for 1 hour. Oh yeah. Oh, I forgot something very important. I spoiled it. I'm so sorry. We'll go back though. We want to come up with a unit. We're going to figure out what is that over 1 hour. So we reduce, that gives us 17.6 miles for every hour. And we use miles per hour, commonly abbreviate like this. So that gives us 17.6 miles per hour. That's pretty fast. So good job, Mia. Way to go. Okay, when you are converting units, remember to put your units in all the time. Your units need to cancel out, so top over bottom, they need to reduce out. And we're multiplying, and things that are equal because that's multiplying by 1. It doesn't change anything. And we can compare quantities just like we compared shirts, and we can convert units to things that just make more sense. Have a fantastic time on your homework. Yeah, you're great.